Okay, so the kind of eye trackers we work with are little cameras. We work with an eye tracker called a remote eye tracker, and it's essentially a little camera that sits, if you're on a computer, it'll sit under the monitor of a computer, and it shines this infrared light at your eye, and you can't see it, but the light bounces off your eye, and the camera is able to pick up the reflections off your eye, and from those reflections, it can correlate where you're looking on the screen. And we got interested in this maybe 7 years ago, 6 or 7 years ago, when we were trying to find ways to have more secure password authentication. So rather than just typing in your password, we had a couple schemes that were a little more secure, and we came across this idea of using an eye tracker to enter your password. And so rather than typing in your password, we've developed various schemes where you would, say, look at things on the screen, and then as you look at them, the computer would know if you correctly entered your password. Well, things are changing pretty rapidly, and I think people can expect to see some new technologies like this filter into kind of everyday computing. And eye tracking you might not see right away. Right now the main hurdles is there's some cost for the actual camera. It needs some higher powered optics than you would have in, say, like a webcam. But you think about the webcams, they used to be several $100s to buy or more. Some of them were many hundreds of dollars, and the prices come down with market forces. And so I think you're going to start to see more eye tracking systems for kind of everyday usage. And right now the market has been more for research purposes, or also for disabled. So if someone, for example, can't move and need a way to input something to the computer, then eye tracking has been one way that's been done. Parallel computing is when you have lots of processors, lots of little computers working at the same time. And so a good example of that is in your iPhone or smartphone today, you can play some pretty nice, some games that have some really nice graphics. And the way that's possible is in these devices today, like your smartphone, to process the graphics, there are actually, in many cases, dozens or hundreds of little processors that can handle little sections of the screen for animating what's happening on the screen. And if you expand that to not just handling graphics, but kind of everyday computation, then that's the idea of parallel processing. It's a little more complicated than having a single processor, because now you have to be able to take some problem and split it up in a way that all these processors can work on them. But that's the other way the industry is going today. You can't buy a computer nowadays that has just one processor in it. When you buy one from the store, it will have dozens of different kinds of processors inside.